Welcome back. In this screencast, we're going to take a look at specific shapes whose volumes are easy to find. And the one that we did in the last screencast, in case you missed it, or in case it's a long time since you watched it and you're like, what in the world is that? That's the volume of a prism, and the volume of a prism is length times width times height. So we take the 3 dimensions of the prism, we multiply them together, and that gives us the number of unit cubes that fill the space. So the obvious next question is, what is this volume, right? Where we know what's going on with the circle, and we know that there's some height here, and so what's the volume of a right circular cylinder? Well, this isn't too bad. What's this length times width anyway? Well, that's the area of the base. That's length times width. And you'll recall from the previous screencast that we just took that length times width, that base of unit cubes, and we multiplied by the height because that's how many we can stack going up the prism, right? So the same kind of idea happens here. We want the area of the base times the height, right? This part is the area of the base. So this part is the area of the base. Well, what's the area of the base? It's the area of a circle. And that's why the volume of a cylinder is pi r squared times the height. It's not an arbitrary thing. It's that we find the area of the base and multiply it by the height. Okay? Okay. Couple of other things to consider, neither of which can be demonstrated in this video. What happens when everything comes to a point? Now, when you're an elementary teacher, there are plenty of excellent ways to describe this to children. You take a pyramid with a base of a certain size, and you fill it up like a cone, like an ice cream cone, like an ice cream pyramid. You fill it up with sand or salt or whatever, or water, something you have handy, and you start pouring those into a prism with the same height and the same bases, right? The same size base. And when you do that, you will figure out that 3 of these fill a prism with the same shape of a base and the same height. 3 pyramids are necessary. And because of that, the volume of a pyramid is 1/3 times the area of the base times the height. Now, why do we say big B as area of the base? Because the base of a pyramid could be pretty much any shape you like. It could be a rectangle like this, but it could be a pentagon or a hexagon or whatever, and it doesn't matter. Whatever the area of the base is, we take 1/3 of that and multiply by the height. Really what we do is we take the area of the base, multiply by the height to figure out what the prism is, and then chop it into thirds. And that's the same kind of thing that happens over here. We can take a cone, right? We can take a cone and we can try to find the volume of a cone, right? It's the same idea. Things that come to a point operate in like manner. So we would expect 1/3 area of the base times the height. But we're not just going to write a big B here. We're not just going to write a big B here because we know what the area of the base is. The area of the base is the area of a circle. So this pi r squared is the area of the base, and you can confirm with experimentation that if we find a cylinder with the same base radius and the same height, 3 of these cones will fill that cylinder. 3 of the cones will fill that cylinder. So now we can deal with prisms, We can deal with cylinders. We can deal with cones and pyramids. The only thing that we can't deal with, and there's just no good way for us to justify this, there is just no good way for us to justify this, is that the volume of a sphere is 4/3 times pi times the radius cubed. If you have ever taken the calculus, we take a semicircle centered at the origin, and we revolve it about an axis, and we can do that in several ways that are taught in our calculus 2, and we can justify in that way that the volume of a sphere is 4/3 pi r cubed. There isn't a really good way to show that to young people, which is why we don't usually show it to the very young. This is a formula that's a little bit beyond the math you'll teach to young people. So let's pause to make sure we can do something. Let's find the volume in cubic inches. Let's let's find the volume in cubic centimeters. And then let's find the volume. Wow, that's just terrible. In cubic feet. Pause the video, make sure you can find volumes. Okay, so I told you should pause the video because there are the answers. Area of the base times the height, 1/3 area of the base times the height, 4/3 pi r squared. And we have cubic units, cubic units, cubic units. Those are important to remember. Well, good. I hope that this was helpful to you, and I will look forward to seeing you in class to explore the ideas more.